is instead of looking at programming, we will look at some of the inbuilt functions in MATLAB which people use very frequently. As when you are writing, we are going to write programs, you will use these inbuilt functions frequently. Therefore, I will discuss today only the inbuilt functions available in MATLAB. So, let us start. To start with, I will start with the help feature available in MATLAB. Let us go to the next screen. Now, unlike many other programs, MATLAB comes with a very good feature which is called help. It has an extensive help tool which is useful to understand the use of functions which are available in MATLAB. All inbuilt functions, you can get help on each of the inbuilt functions available in MATLAB. The way of getting help is two ways of getting help in MATLAB is available. One is using the command line help function, which is help. So, when you get the command line prompt, command prompt, there you can write help, then press enter. That will bring up a list of help topics. We will see that in a moment. So, that will bring up a list of help topics. Second is, if you know the function about which you want to get help, then at the command line prompt, write help space, then the name of the function. For example, here I have given the name of the function as log. You can give any function that we will come across today. For example, I am taking here log. Then press enter. It will give you help on log. So, everything related to what is log function, how it is to be used, what will be the arguments, what will be the output, what you expect, where you will get error, everything will be available in that help page. So, this is through command line help. Then there is HTML based set of documents which I will show you how to open the HTML based set of documents. What you can do is you can go to the help menu from the drop down bar. So, select the help from the menu bar, there you click, then you will go to the HTML based documentation. Otherwise, you can select help icon, which is a question mark in your MATLAB window. Click that icon, double click that icon, that will open the HTML based documentation. Or you can use F1 function key. So, press F1 function key, that will also open this window. So, this will open as a new window. In that window, you have to write the name of the function on which you want to get help. So, these are two ways of getting help using MATLAB. You can use any of these two ways that you need to use. We can see this example of help from MATLAB. Akira will show us the example of using help. Then comes the size function. Size function is to give you what is the number of elements in a row or a column in a matrix, or what is the number of rows and columns in a matrix. So, you can have a matrix which is m cross n matrix. Then if you write size x, x is the name of the matrix, size x, then it will give you the result will be number of rows and number of columns. For example, here we have given x as a 3 column and 2 rows matrix. So, 3, 5, 9, 3, 7, 1. So, there are 2 rows and 3 columns. Now, if I write size x, then it will give me 2 rows, therefore 2, then space 3, which is 3 columns. So, it indicates that it is a 3 cross 2 matrix. Similarly, instead of writing this way, you can write AB is equal to size x. AB is within square bracket, AB is equal to size x. A comma B or A space B. As I have told you earlier, as we discussed earlier, A comma B and A space B within square bracket means it is a matrix, it is a row matrix, and A and B are the elements. The elements in a row matrix can be separated by space or by comma. Here I have shown you comma, you may use space instead of comma. So for the same matrix X, if I write AB is equal to size X, result will be A is the row, B is the column. So A will be 2, B will be 3. Similarly, we can give length X, length length X. Length X always gives the largest dimension of the matrix, which means suppose it is a n cross n matrix and m is greater than n, then length X will give you m. If n is greater than m, then length X will give you n. For example, if it is a 3 cross 2 matrix, then length X will be 3. Now we are seeing a 3 cross 2 matrix. X is a 3 cross 2 matrix. Therefore, length X is 3. Had it been a 2 cross 3, matrix, again the length would have been 3. But had it been a 3 cross 4 matrix or 4 cross 3 matrix, then length will be 4. Then num L or that matrix that gives you the total number of elements in the matrix. So for example, in this 3 cross 2 matrix, total number of elements is 6. If you have a m cross n matrix, total number of elements is m into n. So it will give you m into n. Result will be m into n. It is a 3 cross 2 matrix. Therefore, 3 into 2 is equal to 6. So answer will be 6. So this is what you can test using MATLAB. On the MATLAB screen, you can see this. So these are some important size functions. Then there are some special functions. The most important one that you will use is pi. You need not define pi, or you need not write anything for pi. You can use always pi as pi. That gives the mathematical constant pi, which is 22 by 7, or in MATLAB it shows you 3.1416. Please remember that normally by default MATLAB gives you answer up to 4 decimal points. So after decimal point there will be 4 numbers. So pi is answer is 3.1416, 4 decimal points. Then you can use imaginary number as I or j. So we have shown here I and j both represent imaginary number, and I means answer is 0 plus 1.0000, that is for decimal points I, or 0 plus 1 into j. So that is how you represent the imaginary number. Then INF represents the infinity that we use. Actually, infinity occurs many times during calculation when we divide something by 0. So division by 0, infinity this represents, or this points to a division by 0. So if you get INF or inf, it represents infinity. So 7 by 0, it will show you warning divided by 0, and answer will be INF. Similarly, NaN, not a number. This NaN stands for not a number. This occurs when calculation is undefined. For example, 0 by 0 is undefined. So that will be divided by 0, answer is NaN. So these are some of the special functions that we have come across while we are using MATLAB. Some of them you will use in your programming. Definitely you will use pi, then I or j. Sometimes you may use NaN, sometimes you may use INF. The next one is common math functions. Some of the common math functions. These are some common math functions. ABS is for absolute value of x. For example, if I take ABS of -4, it will give me 4. If I take ABS of 4, it will also give me 4. ABS is absolute value of x. So this is the positive value. So whatever is the positive value, that will come as the ABS. Similarly, SQRT, it finds out the square root of x. So square root of 16 is 4. Then nth root is real nth root of x. Remember, this real is important. It finds the real nth root. It does not find the complex root or imaginary root. It only returns the real root. For example, if I take 8 nth root 8, 3, then answer will be 2. If I take nth root -8, 3, answer will be -2, because -2 to the power 3 is -8. Then as you know, it is a cube root, which means I have 3 roots. Now the other 2 roots are complex conjugate of each other. Since they are complex, it will not show in the answer. Answer will be only the real number, which is -2. Then sine of x. Sine of x gives you, returns the sine of the value x. If x is less than 0, then it will be -1. If x is equal to 0, it will be 0. If x is greater than 0, it will be +1. For example, if I write sine -18, it will give me -1, because -18 is less than -1. Same place, if I write sine 0, it will return 0. If I write sine 16, then it will give me +1. Similarly, REM x, y. This REM stands for remainder. Remainder of x, y. So if I take REM 15, 7, then it will find out what is the remainder of 15 divided by 7. Now 15 divided by 7 gives us a remainder of 1. Therefore, REM 15, 7 will give me 1. Had it been REM 7, 2, then it will be how much? 7 by 2. 7 by 2 is 3. Then remainder is 1. So again remainder will be 1. So this way you can find out the remainder of a division. If you are using a division and you want to find out its remainder, you can use this function. Then exp x, which is exponential to the power x. So if I write exp 100, it will give me this answer, 2.0226 exponential 005. E005 means 2.0226 into 10 to the power 5. Now what is E? What is exponentiated here? It is E, which is the Napierian, which is approximately equal to 2.7183. That is the value which is exponentiated. And then log. Log x gives us the natural log of x. So you can write log 100, that is natural log, not log 10. Log x is natural log. So log 100 will be 4.6052. Don't get confused, it will not give you 2. It will give you 4.6052. Whereas log 10x is common log x, which is with base 10. Log with base 10. The log x is log with base e. This one is log 10x is log x, log of x with base 10. So now log 10 of 100 is answer is 2. So these are some of the common math functions that you will come across or you will be using when you are writing your MATLAB program. Then let us look at the random numbers that we can use in MATLAB. Sometimes in MATLAB, when you are writing programs, you will be required to use random numbers. So let me give you some examples of random numbers. First example, or the most common example, is RAND, R-A-N-D of n. That gives you a n cross n matrix of random number elements, and the random numbers are between 0 and 1. Suppose we take a 2 cross 2 matrix. So rand2 is, these are 4 random numbers. It's a 2 cross 2 matrix. Answer is a 2 cross 2 matrix which has 4 random numbers. Now, if I want only one random number, then I can write rand1. If I write rand1, then I will get only one random number. So it will be a 1 cross 1 matrix which is a one random number. Okay. So you can generate a random matrix, square random matrix whose elements are random numbers. A square matrix whose elements are random numbers and whose size is n cross n using the rand function. The same rand function you can write rand m comma n. If you write rand m comma n, it is going to give you one m cross n matrix of random numbers. Elements are between 0 and 1. So write rand 2 comma 2. If I write rand 2 comma 2, it will be a 2 cross 2 matrix. I am taking here the same matrix. So rand 2 cross 2 is the same matrix, same random numbers. But if I want a list, a row matrix, a list of 10 random numbers only, I can write rand m comma 1. So I will get only a row of matrix, row of random numbers, m number of random numbers there. Or I can write rand 1 comma n. That is going to give me a column of random numbers. So that is what we can use. So you can generate n number of random numbers. You can generate matrices of random numbers using the rand function. Then there is another function rand n. Rand n gives you a n cross n matrix or a square matrix of Gaussian random numbers with 0 mean and 1 variance. Variance is 1, mean is 0. If you are using statistics, particularly this is useful when we use statistical data, when we require statistical data. But for example, if you are using communication, digital communication or analog communication, there you will use statistical data. There you will require rand n. So it will be n cross n matrix or a n cross n square matrix of Gaussian random numbers. So this you can get in this manner. So the difference is earlier rand is between 0 and 1, whereas this has 0 mean. 0 mean means it can be negative and positive. So you can see that in this example we have got few negative numbers, few positive numbers. Mean will be 0 of those numbers and variance is 1. Similarly, rand mn is like rand mn. You will get a m cross n matrix. M can be 1, n can be 1, mn both can be 1. One of them can be 1, other can be non-1, more than 1. So on that way you can generate a list of random numbers or a matrix of random numbers. So that is something about random numbers. If you require random numbers, these are the 4 functions which are useful to you, depending on whether your random number is between 0 to 1, which is 0, it is positive including 0, or it is between any negative to positive, everything. So depending on that you can use rand or rand n. Then let us see the rounding of the numbers. So rounding functions are round, that is the most common one, round, round x. This rounds x to the nearest integer. So whichever is the nearest integer, for example 7.6, nearest integer is 8, it will be rounded up to 8. 7.3, nearest integer is 7, not 8 because it is less than 7.5, so it is towards 7, so it will be rounded towards 7. So answer will be 7. Similarly, fixed x. Fixed x is, it rounds x to the nearest integer towards 0. So if it is the nearest integer towards 0, it will be rounded up. 7.6, answer will be 7 because nearest integer towards 0 is 7. Right. So whatever is after the decimal point will be neglected. It will be nearest integer towards the 0. Floor, FLOOR, floor x, this rounds x to the nearest integer towards negative infinity. This is also similar to a fixed if it is a positive number. If it is a negative number, then it is going towards the infinity. For example, floor minus 8.3 rounded towards the negative infinity will be minus 9. So it is minus 8. Minus 8 is towards negative infinity. So it, because minus 8 is greater than minus 8.3. So it will go towards minus 8. It will go towards minus 8. Similarly, ceil, ceil x. So that rounds x towards the nearest integer towards positive infinity. So ceil minus 8.8 towards positive infinity will be, answer will be minus 9. Okay. So after this we will see some discrete functions. After the rounding functions we will look at some discrete functions. Discrete functions are like factor x. This is the prime factors of x. So if I take factor of 18, 18 has factors 2, 3, 3. 2 into 3 into 3 is 18. All these 2 is a prime number, 3 is prime number, 4, 3 is prime number. So factor this finds out the prime factors of x. GCD of xy, that finds the greatest common divisor. As you know, GCD stands for greatest common divisor. So you take xy, here we are taking 16, 12, answer will be 4. LCM xy, least common multiplier of xy. So 8, 6, answer will be 24. RATS is a rational function. So it is a fraction, rational. So it is fraction of x. So if I write RATS 0.66, how do you get 0.66? 0.66 is actually a fraction of 2 by 3. So 2 by 3 is the exact number, 0.66 is the approximate fractional number. So if you write RAS 0.66, it will give you 2 by 3. Factorial xy, this gives you the factorial. Factorial x, not y. Y is the mistake here. Factorial x, this gives you the factorial of x. So factorial 4 will be 24. Factorial 3 will be 6. So this way you can find out what is the factorial of a number. So just write factorial within bracket the number. Then n choose k. N choose k gives you the combination of n and k. So it gives you possible combination of k items from a group of n items. N choose k 10 3, 10 C3 is equal to 120. So it is a combination of 10 3. N choose k always gives you the combination. So remember that. Then primes x. Primes x gives you all prime numbers which are less than x. If I write primes 4, the prime numbers below 4 are 2 and 3. If you write prime 6, prime numbers below 6 are 2, 3 and 5. So answer will be 2, 3 and 5. So this way you will get prime numbers below a limit, upper limit. Then is prime. Is prime is prime. Is is prime. It will check whether x is a prime number or not. So is prime 100. 100 is not a prime number, so answer is 0. Is prime 7. 7 is a prime number, so answer will be 1. So this is about some useful discrete functions which you will require while you are writing a program. Then we will go to useful trigonometric functions that we will use during writing a program. For example, let us start with sin x. This gives you the value of sin when x is in radian. Similarly, cosine x, tan x, all these sin x, cosine x and tan x, they give value of sin, cosine and tan respectively when x is in radian. A sin x stands for arc sin x or the inverse sin x, and it gives you the value in radian. X is the value that you will give and answer will be in radians. Okay. Sin hx, which is sin hyperbolic x, so it will find out hyperbolic sin of x. X is in radian, accordingly the result will be found. A sin hx is inverse hyperbolic sin x when x will be in radian. Then sine dx, this is sine of degree x. So x is in degrees, sine x is in radian, sine dx is when x is in degree. Similarly, a sine d x is inverse of sine x, and the inverse is expressed in degrees. Now this d you can use for sine, cosine, tan, all this. Similarly, for all these cases you can use d. So these are useful trigonometric functions that we come across when we are going to write programs. Then let us see on the maxima. How to find the maxima? So max x, this gives you the maximum value in a vector x. Suppose x is equal to 3, 7, 1. It's a row vector, and the elements or the columns in that row vector are 3, 7, 1. Elements of row are 3, 7, 1. If I write max x, between 3, 7, 1, maximum value is 7. So a answer will be 7. But if it is a 2 cross 3 matrix, so 2 rows, 3 columns. For example, x is equal to 3, 5, 9, that is the first row, and 3, 7, 1, which is the second row. And if I write max of x, then what will be done is it will find the maxima of each column. So first column 3 and 3, the column contains 2 elements 3 and 3, maxima is 3. So first answer is 3. In the second column it is 5 and 7, maxima is 7, answer is 7. Third column 9 and 1, maxima is 9. So answer will be 3, 7, 9. So it will compare the maxima of each row and write out the maxima. So that will be in a row, it will compare the maxima in each column and write out the maxima as a row. So you will get a row of maxima available in each column. Similarly, AB is equal to max x, within square bracket AB is equal to max x. Same procedure. A gives you the maximum, and B gives you where it is located, where the maxima is located. For example, x is equal to 3, 7, 1. So maximum is 7. So A is equal to 7. 7 is in the second column. Therefore, B is equal to 2. So location is 2. Now if I go to the next example, x is equal to 3, 5, 9, semicolon 3, 7, 1, semicolon 6, 6, 2, which means it is a 3 cross 3 matrix. Now if I find out the maxima, in the first column I have 3, 3, 1. So maximum is 3. So A will be 3. Then second column is 5, 7, 6. Maximum is 7. So A second element will be 7. And then third column is 9. Then 1 and 2. Therefore, the last column in the row is 9. So A will be 3, 7, 9. Now 3 occurs in the first element. So 3 is equal to 1. Then 7 occurs in the second element. So B is equal to 2 for that one. Then 9 occurs in the first element. Therefore that is 1. So B is equal to 1, 2, 1. Then max xy. Max xy gives the row wise maximum between columns of x and y. For example, suppose x is equal to 3, 7, 1, 8, 4, 2. So x is a 2 cross 3 matrix. Similarly, y also is a 2 cross 3 matrix, 3, 5, 9, 7, 3, 1. Now if we are going to compare these two, row wise maximum between columns. So what will be the result? Max xy answer will be, for the first one it is 3, for the second one you can see 7 and 5. So it will be 7. For the third one it is 1 and 9. So it will be 9. So first row is 3, 7, 9. Then we will go to the second row comparing the rows. So second row will be compared 8 and 3, maximum is 8, so 8. So 4 and 7 maximum is 7, so 7. 2 and 1 maximum is 2, so 2. So answer will be 379, then 872. So this is about maxima. Similarly, we can look at what happens in case of minima. Same thing. Similarly, in place of max you write mean, otherwise the description is similar. So mean of x will give us 1 if x is equal to 371. Mean of x will give us 351 if x is a 2 cross 3 matrix. The first row is 359, second row is 371, then answer will be 351. Similarly, AB mean x will give us A is equal to 1, B is equal to 3. For the first row, x is equal to 371. Minimum is 1, it occurs at the third position. So A is equal to 1, B is equal to 3. For the next matrix, the minimums are 3, 5 and 1. They occur at the first column, first position and second position. So A is equal to 351, B is equal to 112. Similarly, mean xy, this is row wise minimum between columns of x and y. So answer will be 351, 341. First row it is 3, then second row minimum is 5, third row minimum is 1, then first row minimum between the two columns is 351, second row 8 and 3, 3 is the minimum, 4, 7 minimum is 4, 2, 1 minimum is 1. So 3, 4, 1. So this is about minima functions. These are the three important functions that you will use. Mostly you will use the first one. Sometimes you will use the last one, and at times you will use the middle one. Okay, now let us look at averaging. How you will find the average. Average is basically statistics. People use it. You can also use it. Average. Mean is mean of the value vectors available in X. So for example, X is equal to 371. The mean is 3 plus 7 plus 1 divided by 3. There are 3 elements. So divided by 3 and add each element. So 3 plus 7 is 10 plus 1 is 11. 11 by 3 is about 3.6. So that will be the answer. Then if I have a 2 cross 3 matrix, x is equal to 359 and second row is 371, then the mean value will be, for the first one it is 3 and 3, so 3 plus 3 is 6, 6 by 2 is 3. Second one is 5 plus 7 is 12, 12 by 2 is 6. Then third one is 9 plus 1, 10, 10 by 2 is 5. So mean will be 3, 6, 5. So mean of each column. So this gives you the mean of each column, right? And then median. The median gives you the median values of vector x. For example, x is equal to 371. Answer will be 3. Now, how do you find out median? If you have already read statistics, you already know this. Otherwise, what you have to do, let me explain it. First step is arrange the numbers in numerical order. First is arrange them in numerical order. Second is count how many numbers you have. So here we have 3 numbers. First one is 3 numbers, 3, 7, 1. So we have 3 numbers. We counted the 3 numbers. There are 3 numbers, 1, 7 and 1, 3 and 7 are the numbers. Now if you have an odd number, here we have an odd number 1, 3, 7, 3 numbers. So we have an odd number. If you have an odd number, then divide by 2 and round up to get the position of the median number. So if I divide it by 2, so 3 by 2 is 1.5, round it up. So that gives me 3 ultimately. 371, that is up to 3.6. 3.6 I am rounding up to get this 371, right? 3.6, 3.6 rounding up towards 3. So that gives me 3. Otherwise, if you have even number, divide by 2, go to the number that is that position, the position where you get by dividing 2, and average it with the number in the next higher position to get the median. So this is how you get the median. So the first one and the second one, this you can test using these methods, or go to statistics and find out this. Then mode. Mode gives you the value that occurs most often in an array. So we are seeing an array 3717, 7 occurs most, so mode is 7. So this is about averages or statistics that you will use. Now let us come to the sums and products. Now sum, if you write sum, then it sums the elements in the vector. For example, x 371, if I write sum x, it will sum 3 plus 7 plus 1, that will be 11. But in the next one, if I write sum x 359, then next row is 371, then it will sum the columns. Each column will be summed. So 3 is 6, then 5 7 is 12, then 9 1 is 10. So that will be 6, 12 and 10. Right. Product is similarly in place of summation, it will be product. So 371, product will be 3 into 7 into 1, that will be 21. The 2 cross 3 matrix, 359, 371, 2 rows are there. If I take the product, 3 is 9, 5 7 is 35, 9 1 is 9. So answer will be 9, 35, 9. So these are sums and products. And then finally we will come to sorting the function. So if you have a sorting function, so you are given a set of numbers, you want to sort them in ascending order or descending order. So what you can do? So you can write sort, S-O-R-T, sort x. So that sorts the elements in x in ascending order. For example, x is 371, then it will be sorted as 137. So if I write sort x, it will give me 137. So in ascending order, it has been sorted. So lowest to highest. Ascending means lowest to highest. Descending means highest to lowest. Suppose we have got this 2 cross 3 matrix, 359 and 371, 2 rows are there. Then if I write sort of x, then it will give me 351, 379. From where I am getting this 379, 351? It sorts actually the columns. The first column will be sorted, then the second column will be sorted, then the third column will be sorted, and these columns will be displayed. So first column is 33, second column is 57, third column is 91. When you sort it, it will be 19. In ascending order, first will come 1, next will come 9. So it is 19. Then sort x descent. Descent means it will be sorted in descending order. Same thing as in the previous case. I am showing you here only the second example, not the first example, because first example is obvious. The second example will be 379, 351. It will be interchanged. These 2 rows that we got in the first example will be interchanged because it is in descending order. And then sort rows. Sort rows means it will sort rows of elements, sort row elements of x in ascending order on the basis of value in the first column, keeping each row intact. For example, if I have got this matrix, 3 cross 3 matrix, 359, second row is 371, third row is 824, then when we will sort it, it will be 3, 3, 8. So that will be the first column. The second column will be 5, then 7, then 2. And the third column will be 9, then 1, then 4. So because why this is coming 9, 1, 4, 5, 7, 2? Because the columns are intact. First column is remaining intact. Columns are not changing. Similarly, sort rows xn. This will sort row elements of x in ascending order on the basis of value in column n. So it will take the nth column, its value it will take, then it will sort accordingly. So same matrix, if we write x is x comma 2, then the sorting will be 8, 3, 3, 2, 5, 7 and 4, 9, 1. So this is what is going to happen in sorting function. Mostly you will write the first one or second one. Third, fourth you will rarely use. So don't worry about the third, fourth, but remember the first one and second one. Sort x descent. Finally, the last slide is some information about limits when you are using MATLAB. A real max gives you the largest possible floating point number. It depends on two things: version of MATLAB that you are using and the machine that you are using. So the largest number the machine can handle and the largest number the MATLAB can handle, among these two, whichever is the largest, that is this number, real max. Real mean is similarly the smallest number the machine can handle and the smallest number the MATLAB can handle. MATLAB, the version that you are using, that can handle. Between them, which is the smallest is the real mean. Integer max, int max is integer max, that is for integer number, largest integer. Integer mean is the minimum integer. Now you can see here that in the mantissa part or the number part, the last one is 7 for integer max and integer max, last one is 7. Here for the mean it is 8. Reason is if it can handle the number, suppose last part was 5, then the lowest will be minus 5, minus 6. Highest is 5, lowest is minus 6. How this comes? It comes from the positive is counted from 0. So 0 to 5 is 6 numbers, minus 1 to minus 6 are 6 numbers. So this is how it comes. Then overflow occurs if your number or the calculation that you are doing does not fit within these limits, maximum and minimum limits, then there will be an overflow or underflow. Overflow is when the result is too large for the computer program to handle. Underflow is when the result is too small for the computer program to distinguish it from 0. So these are the two things that one has to be careful. Your number, if it is not within these two values, then you have to take special care. That will come to you when you will do programming. Gradually you will come to know that. So with that we come to the end of today's lecture. Now we will see on the examples using real MATLAB. I will ask Akira to show us examples of these, whatever we discussed, those examples. He will share his MATLAB file and show you the examples. Thank you for being with me today. Akira, you can go to the first slide. From the first slide, you can show. Start with the help command. So then. Now you can do one thing. Stop sharing my screen and share your screen. That is better.
I'm sharing my screen right now.
You share your screen and stop sharing my screen. Okay.
Sir, your screen is already off. This is my
Okay.
screen
Okay.
right now showing.
Good. Okay, no, I can see only my screen.
Oh, okay, wait.
Okay. No, not the last one, last.
Now it is clear?
It is clear.
Okay.
I think students can
Here
see.
it is help log.
Now you can see it says help log. So the answer is now MATLAB is showing you log, then with a space it says natural logarithm. So log means you are finding out natural logarithm. Log x is the natural, then it describes what is it, and log x, that is how you will use it. That we will see later. So this is about help log. Only help, just show help. Help, enter. Only help, enter, it shows a list. Okay, so it shows you it does not show the list, it should say list.
It shows what is, the last help command. Suppose I will type help log, and now if I type only help, it will show the last help command.
No, then you
whatever
do,
I type.
so clear all, first clear all, then help. Clear all CLC, then help. Help. No, it shows the same thing. Help should give a list of commands. All commands shown in available in MATLAB. Okay, maybe this is a new version, so it is not showing all commands. Anyway, so help is over. Next. Help exponential, right? Okay, so this part is over. Help part is over. Now let us go to the next part, pi. It shows you the value of pi. Then I and j. I and j, you can see the values that we showed are available here. So pi I j, then
ABS.
ABS of -5 is 5. ABS of +5 is 5. That also you can show. Then sine, SIGN. Sine of -5 is -1. Sine of 0, sine of plus some number is 1. Sine of 0 is 0. In 0. So ABS sine, then what were the other things? Let us check what are the other things.
Okay. It is not showing me.
No, I will see from my side.
Okay. Okay, let me know the command. I will.
I will tell you the command so that you can.
Yes.
Use it.
Yes.
Fast को पढ़ा. Size. So first write x is equal to some vector. Give x is some vector. Then size. Okay. So they can see what is the size. Tell them what you are showing. Minima इसको दो था कर लेती size.
Here I have taken a vector naming as x. So it contains 2 rows and 3 columns. So when I type size x, it will give you here the number of row and the number of columns. So similarly,
okay. So then write AB within bracket AB within bracket square bracket within square bracket AB within square bracket is equal to size x. It shows you
so
A is the row, B is the column. A is equal to 2, B is equal to 3 for the same vector size, same vector x. Okay. So then next is
length.
Length. Length is 3 because it is a 3 cross 2 vectors. So length is 3. Then NUML. NUML or NUMEL?
NUMEL. It will show the total number of elements in the vector. It will return the total number of elements, but length x will always return the greatest number, whether the row is greater or column is greater. Suppose row is greater than column, then it will show you the number of column. If suppose the number of column is greater than row, then it will show you the number of column. So look at again here. It is a 2 cross 3 matrix. So here the number of column is 3. So when I type length x, it will give us the larger one. The larger one is the column. Here it is the number of column is 3. So it will give you 3. But NUMEL always give you the total number of elements in that vector, in that matrix.
Which is n cross m, which is 6.
Yes. Suppose I will take another matrix. Now if I type normal, then it will give you 8. 8 means the vector x contains 8 elements. Here in the first row it contains 4 elements. Again in the second row it contains 4 elements. So total it contains 8 elements. So norm AL always give you the total element contained in a vector.
NUMEL, number of elements. NUM is number, EL is elements. Okay, now sine.
Sine.
Sine, SIN. Sinusoidal.
Yes.
Sine of.
So here sine 90. It will
This
give
is
you
not
the
degree.
approximate.
Now you can see it is not degree. It is in
Yes.
radians. 90 radians. The value is for 90 radians. Had it been degree, it would have been 1. Sine D 90. Right, sine D 90, then they will see.
90?
Sine D 90. Not sine.
So it will give you in
1.
the form of degree.
Now it is in degree, so it is 1. Otherwise it was in radian. So this is a common mistake that people do. So if you are using degree, then you have to write sine D. If you are using radian, then you are to suppress D. So if there is no D, remember that it is in radian. You are finding the value for radian. Similarly, find A sine, arc sine.
সেটা আউটসাইড থেকে
কোটা কইলো মা
Which one?
কোটা arc sine না sine ro hela if it is sine x then it is x is in radian. For example, we saw now sine 90. You know sine 90 degree is equal to 1, but when we give sine 90, akla utter dala sine 90.
Okay.
Sine 90. Now you see sine 90 is not equal to 1, it is something else. But you expect that sine 90 should be 1 or sine 45. Sine 45 should be 1 by root 2. So that is not happening here. Why it is not happening? Reason is it is taking 90 as radian, 90 radian. Now if I write sine D 90, then I am forcing the computer or MATLAB to calculate sine in degree, sine degree. So write sine D 90, that will be 1, sine D 45, that will be 1 by root 2.
A sine D means it will return you the inverse of sine in degree. So sine inverse 1 means it is 90 degree. If I simply write A sine 1, then it will not return 90
degree
because it will give you in the form of radian. But if you want the value in degree, then you have to again write A sine D.
Same thing for hyperbolic function, sine hyperbolic, A sine hyperbolic, tan hyperbolic, cos hyperbolic, or sin, tan, cos, arc sine, everything you can do in this manner. So we will not go to cos, tan, etc. We will go to the next one. Sine hyperbolic dekhe diyo, sin h. No, it is only sin h, sin dh nahi hote.
Sine hyperbolic 90.
Sine hyperbolic achi, sin h achi, but degree re nahi cheta. If you are calculating hyperbolic function, you have to convert degree into radian, then use it.
Yes.
Okay. So this is about sine. Then little
Trigonometric function. Next we will look out exponential. So here if you simply write exponential means e to the power.
Exponential 1 कर दियो तो जान देबे eta कितने exp1. This is
here exponential means
e is equal to 2.7183.
So when you write exponential 2 means it take the square of this number. So if I calculate square of this number, look at, it will give you the same. You can type exponential 2, otherwise you can write the value of e and take the square. You will get the same result.
So if it is always difficult to remember value of e, therefore you can always write exponential exp. That is a better way. Then log and log 10.
Here log means simply it will give you the logarithmic, not a base 10. To get the result
log
in
base e.
10.
Log means log base e, natural log or log base e.
Now the log 10 means it is the logarithmic with base 10. So when you type log 10, it will give you 1. But simply log always written you logarithmic with base e.
Similarly, anti-log देखते टिके a log अच्छी नहीं देखती हो अच्छी तो a log
A log is not working.
कौन लिखला? Did you mean?
It may not be a log. It may some different command.
देखी दोनों log रा help log कर दिया जहाँ पूछो. अच्छा a log नहीं e to the power करा जाए पूरा.
Yes.
e to the power करा जाए. Exponential of log कर दो से अच्छी ठीक.
Look, log exp. Suppose I will write 2. It will give you 2. It means exponential is the form of a log, anti-logarithm. So when I will take log of anti-log of 2, then log and anti-log will cancel out. It will give you only 2. So whenever you require anti-log, you just type exponential of this number. You will get the anti-log of this. So here suppose I want to calculate the anti-log of 1. It will give you this.
And log of this value is 1.
Yes, log of this value equal to 1. Look at log of this value equal to, it will give you 1. When you take the anti-log of 1, it will give you this much. So exponential is always represent the anti-log. So that when you take exponential of log of suppose 2, exponential log will cancel out, it will give you only the number 2. Similarly reverse you can do also, like log exponential 4, it will give you only the number 4.
एबे random number देखला rand.
Suppose I will write rand 2, it will give you 2 cross 2 matrix, and the number is in between 0 and 1. All the number are in between 0 and 1. Suppose you want to get the random number of the matrix, suppose 2 cross 3, then type rand 2 comma 3. It will give you a matrix of random number with the order 2 cross 3.
Then गोटे रो रे 10टा रहिबो. rand 10 1 देलो.
Yes, rand
10 1 गोटे कॉलम रे रहिबो.
Yes.
गोटे कॉलम रे 10टा रहिबो.
10 row, the first one is represent the number of row and the second element represent the number of column. So here it will show you 10 row with single column. Similarly, if I want to get the vector with 10 column and single row, then I can interchange 1 comma 10. It will give you the 10 column with a single row.
गोटे काम कर दी थर सेम कमांड टाको दियो ताल जानि परिबे जे रैंडम नंबर होची एक्चुअली गो सेम नंबर टा रिपीट होनी जानिबे
yes let me show. Look at here random 2 in the case in the first case you will get the number 0.7060 and in the second case it is different to the first one.
These so numbers are randomly generated, which means these are randomly generated. It is not same.
Yes.
Every time you give
at every time you will get different numbers.
Different numbers, right? Rand n देखी देखा अब rand तक गला
it will show you the Gaussian randomness.
0 mean and sigma
1 variance.
By default variance is 1. Variance हमने change करके देखा होते ये तो default तो 1.
Command I mean the command itself having the by default 1.
By default 1, right. Hela. So rand सरला और कौन रहिला छाड़ले कौन max max mean देखे दो.
Yes. Here here a matrix X, it is shown in the command window. When I will take max of this matrix, it will give you the maximum value in every column. Here in the first column 1 4, from 1 4 the maximum is 4. Similarly in the second column 2 5, the maximum one is 5. Similarly in the third column 3 6, the maximum is 6, and last column 9 is maximum. So it will give you the maximum value in every individual column. Similarly if I write mean, it will give you the minimum value in the different column. So in the first column the minimum is what 1, so it will return you 1. In the second column it is 2, so it will return you 2. So this is the basic about the max and mean.
दीटा करके देखा x गोटे वेक्टर y गोटे वेक्टर तापरे max of xy mean of xy.
So here the two matrix, one is y having these values and x is having these values. So when I take max x comma y, so it will return you the, here I have written x then y, so it will return you the max number of x vector first then y vector. So here the max value of
first row of x will be compared with the first row of y. सेमती एक रेशियो फर्स्ट रो को फर्स्ट रो रे कॉलम वाइज कंपेयर हबो. फर्स्ट कॉलम टा कंपेयर करियो फर्स्ट रो रो फर्स्ट कॉलम कंपेयर हला व्हिच एवर इज मैक्सिमम दैट विल कम फर्स्ट. सो दैट इज 8 तो सेटा.
Yes. It will compare every element. Here it is 8, here it is 1. So 8 is bigger, so it will give you 8.
Then
so
5
in the
and
second
2.
Case, 5 and 2.
So it will be 5.
It will return you 5. The maximum number, it will return always the maximum by comparing both the matrix individually by individual element. So if I look out these 3. So 7, 3, if I compare 7 and 3, then 7 is the greater number, so it returns 7. So if I find the last element of both the matrix, here it is 6 and here it is 9. So 9 is the greater number, so it will return you 9. Similar case, if I type mean x comma y, it will compare every element of x with every element of y, and it will return the minimum number. Which one is the minimum? It will return.
So max min हेगला सब तो कहीगला तो कौन बाकी रहला कि सब करे देले प्राय रैंडम हैला हां मीन वेरिएंस रहगला मीन मीडिया
ओके
मीन मीडिया मोड सेटा देखिथियो
So here the vector x contain 1, 2, 3. Then if I take the mean by typing just mean x, it will return you the mean of these three numbers. Here 1, 2, 3. If I add 1, 2, 3, it will give you 6. And then if I divide 6 by 3, as there are 3 elements, so I will divide that sum by 3. It will give you 2. Similarly, if I will take another matrix contain this one, here if I calculate mean, it will give you the mean of every column. So in the first column 1, 8. 1 plus 8 is 9, and as there are 2 elements, so it will give the mean of these 2 elements. 8 plus 1, 9 divided by 2 will give you 4.5. Similarly 2 plus 9, it is 11. So when I divided by 2, it will give you 5.5. So mean y means it will return you the mean of every individual column. So to get a more clear understanding, I will show you one more example. Look at. So here from the first column it is 4, 2, 7. So total here it is 11, 13. So 13 by 3. 13 by 3 is give you 4.33. Similarly in the second column it is 506. 506, if you add 506 you will get 11. So 11 by 3 is 3.667. Similarly here in the last column there are 3 elements. One is 2, 9, 3. So when I take the mean of these 3 elements, it will give you 4.6. So mean will return you the mean of a single column, every individual column. Then if I calculate the median. Sorry, median.
Media बोले खाली. अच्छा.
Here it is x, and when I take the median of x, it will give you 2. It will arrange. Look at. I will show you by taking another example. Y. Look at y having the matrix with these elements. When I take median of y, it will give you
median. I described them how to calculate. Add them if it is odd number, then find out what will be it. It is here. It is even number, so divide by 2. So add them, divide by 2, then round up. So that is what is being done here. Then how gote karo mode पे का गोटे नंबर रिपीट हेतिवार अछि.
ओके.
जोटा रिपीट हबो से नंबर टा the frequency actually जोटा बेसी frequently occur करछि that is the mode.
Sir, हमें जदि 2 digit number नबा
how about 2 digit नेकी
Yes,
देखा
it will give you 2-digit number. No problem.
result will be 2 digit 2 digit नहीं पर n digit नहीं पर किसी असुविधा नहीं जहाँ भी नंबर चलो.
Here in the vector x, 12 is repeated maximum time. 12 is repeated for 3 times. So mode always give you the maximum repeated number. So it
highest
will give
frequency
you 12.
mode is actually highest frequency.
Actually,
mean बाहर कर दियो से x रा mean बाहर कर दियो media बाहर कर दियो देख दियो.
mean means you have to
Add
sum
them.
all this. So
Add them then
Let me
divide by
see.
the number of elements.
let me use sum command. Sum command will give you the sum of all total elements. So it will return you 2, 2, 3. So here are how many number? 1, 2, 3, 4, 5, 6, 7.
So size करके बाहर कर
there
दो.
are total 7 numbers.
नहीं size करके सेटा बाहर कर size करो 7 दबो ची.
length
हाँ जो टाइप करना size करो length करो जहाँ भी करके जाए.
yes, length. So here we calculate mean is this much. So but manually we can also calculate to check the number. So how can we calculate? Sum
x
divided by
length x.
length x. Look at here the mean is what is 31.8571. Now we calculate the mean by manually. It will give you the same thing. So means it always give you the sum by total number of element.
Now I hope you can understand the beauty of MATLAB, power of MATLAB. Instead of writing the program for sum, then divide, find out length, you need not do anything, simply write a mean, you get the mean value. That is the beauty of MATLAB. Then sum तो होगा product देखिए दियो PROD.
Okay. It will multiply all the element. So let me take another example which will easy to understand you. Look at 8 2 ja 16, 3 ja 48. So it will give you 48 product of all the elements.
सम प्रोडक्ट करा अच्छा मैक्सिमम रियल मिनिमम रियल करे देखे चलो.
Real max.
रियल मैक्स रियल मीन खाली तो रियल मैक्स ले आसछि रियल मैक्स खाली आसछि.
Yes.
एटा सबटु बड़ नंबर एटा हैंडल करी हबो. रियल मीन कर दियो लास्ट डिजिट ताठु गोटे बड़ थियो सेटा 1 अछि एटा 2 हबो.
Yes.
7 थिले 8 हबो माइनस रे. अच्छा इंटीजर मैक्स इंटीजर मीन कर देखे दियो.
$32 bit.
इंटीजर मीन बस. I think we have seen almost everything that we discussed. और किसी डाउट अच्छी पचार पिले ना कमेंट अच्छी कह तापर अक्षर तार प्रेजेंटेशन देखो. हाँ सेमिनार प्रेजेंटेशन देखिए अक्षर.
YouTube बंद कर देता.
हाँ यूट्यूब बंद कर दे.
ओके ठीक है. किसी डाउट अच्छी बोले पचार ना किए को प्रोग्राम करथिबो सेतरी किसी प्रॉब्लम अछि
गला थर कहली प्रोग्राम करिया को करछ किछि प्रोग्राम न करबो जदी आ तुम सिखियो
आज्ञा सर
करछ कोन करछ को प्रोग्राम गोटे हम रन करबा एथरे लिखिया को प्रोग्राम डाको से लिखियो लाइन बाय लाइन डाको हम देखि देखि दिवा
सर एमती पर्टिकुलर को प्रोग्राम करथले कि
जोटा भी तुम तो प्रोग्राम करथियो ना जे प्रोग्राम टाटा कम करथिली कह जाय प्रोग्राम करिवो भूल हो ठीक हो प्रोग्राम गोटे करिवो जदी किछि प्रोग्राम करिछ प्रोग्राम रो लाइन बाय लाइन डाको हम देखिया
किसी प्रोग्राम करथिबो जदी जहा भी
सर एडिशन मल्टीप्लिकेशन एमती करथिलु
खाली एडिशन मल्टीप्लिकेशन अच्छा गोटे प्रोग्राम कल देखिया करि परियो एक टू 100 जाय मिसेवा गोटे प्रोग्राम लिखो ना फॉर लूप पढ़ाइनी अच्छा एबे हबनी हो ठीक है हां नहीं फॉर लूप करेनी ना पढ़ेनी फॉर लूप सम तो लिख देल संगे संगे हो बट फॉर लूप रे करी के देखि थांते जे पढ़ाइनी फॉर लूप पढ़ाऊ अथरे गोटे तो करी
तीन तो लगे देले जो तो
1 को
1 2
1 से कोलोन 100 दे देले गला
नाले फॉर लूप रे कला हो
जे बे तो कराई नहीं अथाओ परे करिए ठीक अछि तो तुम प्रेजेंटेशन देखा करो
So good evening everyone. Today I am going to present a seminar on how we evaluate the performance of a parallel algorithm. So the performance analysis means it is the study of our algorithm, how it performs with various parameters, how it behaves on various parameters. If we change some parameter, then how it will perform. This is called the evaluation of the performance of an algorithm. So here, suppose I have the parameters like message startup cost, problem size, and the processor count. As I am interested on the performance of a parallel algorithm, I have these three parameters. So I will look out how the algorithm will behave if I change these three parameters. Suppose I will change message startup cost, या problem size, या processor count. Suppose I have a algorithm and I am executing with the 10 number of processor, then I will check whether if I change the 10 number of processor to 20 number of processor, then how my algorithm performs. So this is called the evaluation process of the performance of an algorithm. So to check the performance, here that two terms is mostly used. One is speed up and the second one is the efficiency. These two terms are mostly used to determine the performance. One is speed up, second one is the efficiency. The speed up of a system of a parallel algorithm can be calculated over a uniprocessor system. Suppose we have a sequential algorithm and we are running that sequential algorithm in a single processor machine. So suppose it will take T1 time to complete whole total task in the sequential algorithm in a uniprocessor machine. Again, if we execute a parallel algorithm with a machine having the P processor, and we will complete that task suppose in the time TP. So to calculate the speed up of our algorithm on comparison to the sequential algorithm, we will calculate by simply the time taken by the sequential algorithm divided by the total time taken by the parallel algorithm in a machine containing P number of processors. So suppose you can say if we increase the number of processor, the speed up will increase. Yeah, definitely it will increase, and it will give you, if you plot the graph between the number of processor and the speed up, it will give you a linear graph. But actually in practice, you will not get a linear increment in the speed up, and it is very hard to achieve by increasing the number of processor. Why it is very hard? Because as we increase the number of processor, the communication, I mean the internal communication between these processors will increase, so which will create a problem on the increasing in the speed up linearly. So you will not get the linear speed up by increasing the number of processors. So this one is the most uh, drawback. Similarly, in the efficiency means the fraction of time that a processor spends on doing useful work. So how we will get the efficiency of an processor? Just by looking how much time it spends on doing some useful work. When we execute our algorithm, the processor will do so many things like computation. Uh, Another one is the communication between two processors, and in some time it became ideal. So how much time it spends on doing a useful work, this is called the efficiency of that processor. So efficiency is simply calculated by doing the total speed up by the total number of processors. Suppose the speed up is 100, and we will get the speed up 100 by taking suppose 10 processors. So then if you calculate the efficiency, so 100 by 10 it will give you 10. So look at, so suppose a parallel system contains 10 processor and achieve a speed up 8-fold. So in this case, if we calculate the efficiency of a single processor, then we will divide the speed up by simply the number of processors. Here the speed up is 8, and if we divide the 10, then it will give you 0.8. To get the percentage, simply multiply 100, it will give you the 100 percentage. So in this way, you can calculate the efficiency of an processor. Now the now the efficiency will help us to determine the scalability of an parallel algorithm. So what is the mean by scalability? Scalability of an parallel algorithm is just, it measures the capacity of the algorithm, that how effectively it utilizes when we increase the number of processors. So scalability is nothing but it is just measure the capacity of your algorithm, that how effectively it utilizes when you increase the number of processors. This is the scalability. So efficiency measure the scalability. So it will give you the scalability, give you the best algorithm architecture just by determining the optimal number of processors that you can use to get the maximum possible speed. Once you know the minimum number of processors that help you to get the maximum speed up, then your task is done. You will get a best algorithm architecture. So scalability plays an important role when we deal with the parallel algorithm. So we must have to care about the scalability. Now one more approach to quantify the scalability is that it will determine how execution time and the efficiency of an algorithm varies with increasing the processor count. Processor count means number of processors. It means if you increase the number of processors, then how the execution time behaves, how the efficiency will behave. It will find from the term scalability. So it also helps us to find the fastest way that we can solve a particular problem in a particular and one more thing, efficiency 50%. Suppose you want 50% efficiency, then you can conclude how many greatest number of processors that you can utilize, you can use to get the 50% efficiency. So now here it is, I am showing the two graphs which will show you how the total execution time depend upon the number of processors. So in the left side graph, it is showing that the total time, how total time behaves with increasing the number of processors. You can get a clear understanding that when we increase the number of processors, the total execution time is going on decrease. Means your algorithm is performance better in a better way. So, but in the right hand side, if we look out the efficiency, when we increase the number of processors, the efficiency is going on decrease. Efficiency is not maintained constant; it is going on decrease. Sorry. So here the small example which is for a 1D decomposition finite difference algorithm with n number of grid and p number of processors. Problem is 1D decomposition finite difference algorithm which contain how much grid? N grid. N is for 120, 8 and 512. These are the two cases where we analyze how total time behave on increasing the number of processors and how efficiency behave on increasing the number of processors. Here the problem size is fixed and the computer is fixed, but we only increase the number of processors